Well, hello. It's a great pleasure to be here today. And on behalf of NovaPhos, I want to thank the ACS and the Green Chemistry Institute for recognizing our technology with this award. Many of you may be wondering, what is phosphogypsum and why is it a problem? Well, to give you an idea of the size of the problem, look at this photo here, which shows a large waste disposal site for phosphogypsum, what's often called a gyp stack. This gyp stack's in Florida and is very large, as you can see. It's about 2.5 miles long, 200 feet high. It contains about 600 billion pounds of gypsum, plus hundreds of millions of gallons of acidic and radioactive processed water. This is just one of many such stacks in the US and around the world. So, gypsum is calcium sulfate and contains about 20% sulfur by weight. There are a number of different sources of gypsum, some natural and some synthetic. Phosphogypsum is waste gypsum generated in the production of phosphoric acid, a chemical product that goes into almost all the phosphates we make and use. And we cannot do without phosphates. They are essential in the fertilizers used to grow our food, including soybeans. They are also critical to many other products, including LFP lithium-ion batteries. For many applications, there's no substitute for phosphates. So for each ton of phosphoric acid produced, consumes about 1 ton of sulfur as a raw material in the form of sulfuric acid. All that sulfur comes from the oil and gas industry, where it's recovered in refineries and processing plants. That same sulfur that goes into making phosphoric acid then exits the process as part of each molecule of gypsum generated in the production, about 5 tons of gypsum for each ton of phosphate. Because of its origins, phosphogypsum is acidic and contains many of the impurities from the phosphate mineral used in the process, including radioactive impurities. That makes it hard to use this gypsum for most of this gypsum for any other purpose. The NovaPhos process can take this gypsum and extract the sulfur for reuse by the phosphoric acid producer, or to make other fertilizers like ammonium sulfate. The other product out of our process is a solid calcium silicate, useful in construction. How does it work? We combine gypsum with silica sand into an agglomerated feed. The feed is processed using conventional pyroprocessing equipment, where heat decomposes the gypsum, releasing the sulfur content in the form of sulfur oxide gas and forming stable calcium silicate solids. Our technology is being patented in the US and around the world, just about everywhere phosphates are produced. So, what are the benefits of this? Whoops, wrong button. What are the benefits of this process? The phosphate industry produces about 30 million tons of gypsum each year in the US alone. That gypsum contains about 6 million tons of sulfur. Sulfur that phosphate producers are buying, using, and then throwing away. Something like $1.3 billion a year. With our process, that sulfur can be recaptured for reuse, leveraging circularity to reduce operating costs. Of course, reusing waste phosphogypsum also means it won't end up in a stack like the one we saw on the cover slide. That means capital and operating cost savings, including avoided stack closure and post-closure care costs. And post-closure care costs here go on for 50 years after closure. It also means fewer costly environmental problems, and there have been environmental disasters associated with these gyp stacks. And our calcium silicate product can be used in construction. For example, as a supplementary cementitious material, or an SCM, displacing cement in concrete. So these applications for calcium silicate will have a similar value to the avoided sulfur purchases and contribute to reduced use of construction materials for cement and other purposes. In short, our technology can help the phosphate industry to become more competitive by reusing a large waste stream. This will bring important economic, security, and environmental benefits, and really has the potential to change this industry. I'd like to thank the NovaPhos team, 2 of whom are here with me, named inventors on the process, Mark Vignovic and Dave Blake. And we are indeed a small company, less than 20 employees overall. So we really appreciate the support of organizations like the American Chemical Society that inspire us to try to be inventive. Thank you.